Hey, how you doing? Welcome back from break. Hope everything went well last week for you. Want to tell you that I was disappointed to realize that we're not going back to school. It's ridiculous, but we'll make the best of this. That's all we can do. Hey, I thought we'd start with this problem here. I kind of threw you guys for a loop in that last assignment we did, gas stoichiometry. I gave you a problem like this, and a lot of you emailed me and said, hey, I'm not sure if I'm doing it correctly, so I appreciate that. This is different. How, think about this. You recognize this as a single replacement reaction, give you 12 grams of zinc and a certain amount of the hydrochloric acid solution. So what's different about this is I don't tell you which reactant is in excess. So we call these limiting reactant problems. So if you remember correctly, what we were trying to do is figure out the moles of hydrogen. So then we could plug it into Pivner to figure out the volume of hydrogen that was produced. But for this problem, let's just figure out the moles of hydrogen. So one way of doing this is to start with one of the reactants and solve the problem, and then do the same thing with the other reactant. So let's start with the zinc. So starting with the zinc, right? We got 12 grams of zinc. Oh, now I forget the molar mass of zinc. I think it's 65.4. Let's just go with that. 65.43 maybe. So that cancels out. Okay, so now the mole ratio is 1:1. So for every 1 mole of zinc, there's 1 mole of hydrogen. So let's figure out what that is. So I'll know in a second if that molar mass is right. I think it is. 12 divided by 65.43 equals 0.18 moles. 2 sig figs, so we got 2.18 moles of hydrogen, okay? So let's just go with that. So now, let's do the same thing. Let's solve for the moles of hydrogen, but let's start with hydrochloric acid. See what happens. So we're given molarity, volume. Remember, start with volume. Let's convert the volume to liters. So 1,000 mils is a 1 liter. That cancels out. Molarity, remember, think of molarity as moles per liter. Okay? Moles per liter. So we got 1.5 moles of HCl for every 1 liter of HCl. Hey, some of you made a mistake using 22.4 there. 22.4 is only for gases at STP conditions, okay, not for solutions. All right, so let's use our ratio. This time it's 2:1. So for every 2 moles of HCl, we get 1 mole of hydrogen, okay? All right, so let's do that. So 0.035 times 1.5. Did I do that right? Yep. Divided by 2, this gives us 0.026 moles of hydrogen. All right, so we get 2 different answers. So look at this. Starting with zinc, we get the 0.18. Starting with HCl, we get the 0.026 moles of hydrogen. So what's that tell us? All right, this is what it tells us, that the zinc is in excess. So if what we're doing here is we're assuming we have enough hydrochloric acid to react with all the zinc. Well, we don't. So whichever reactant gives you the smaller value, that then is what's called the limiting reactant. So this is the limiting reactant, and this is in excess. So limiting reactant problems. If I don't tell you what's in excess, just do 2 stoich problems. Your next assignment, that's what you'll be doing. Okay. Let's just review that one more time. So if I start with zinc, we get 0.18 moles. If I start with hydrochloric acid, we get 0.026, a much smaller value. Because this limits the hydrochloric acid, this smaller value is telling you that the hydrochloric acid limits how much product we get. It's the limiting reactant. This 0.18, yeah, we could get this if we have enough HCl. Okay? All right. Let's do this. I think you can see down here. Let's just kind of summarize this with easier values. So looking at this 1 to 2 ratio. So for every 1 mole of this, we need 2 moles of this. Okay? So let's do a couple things here. Hey, how about if we have 1 mole of zinc and 3 moles of HCl? What would that mean? What would that tell us? Well, it would tell us that this is in excess. For every 1 mole of zinc, we only need 2 moles of HCl. So actually, we would react 2 moles of HCl, and 1 mole of HCl would be left over. Left over. Let's look at something else. Okay, let's look at another. This doesn't. It's not okay. It was working okay. Let's say we have 0.05 moles of this and 0.07 moles of this. Okay, so for every 1 of these, we need 2 of these. So let's take 0.05 moles of zinc, multiply by the mole ratio. It's 2 to 1. So look at this. This is how much hydrochloric acid we would need to react with 0.05 moles of zinc. But we don't have it. So what's that mean? This is in this case, this is the limiting reactant. And this then would be in excess. And that's similar to what happened up here. So what I would suggest you do at this point is just do 2 stoich problems. And whichever one gives you the lower value, that then is the right answer. That's the right amount. And whatever you use, that would be the limiting reactant. The other reactant would be in excess. After this assignment, then what we'll be doing is determining how much of the excess reactant is left unreacted. So that's where we're going with this. That'll be the hardest stoich problem we'll do. Then we'll be well on our way. All right. Look for an assignment today. I'll email you now the next assignment. Okay. So welcome back from break again, and hopefully I'll be setting up a Zoom. You guys can ask questions or just say hi or things like that. Okay. See you then. Bye.